Good afternoon, my dear students. Welcome to one more amazing session from Infinity Lane by Sri Chaitanya. How are you all? Can you able to see me, hear me? Can you able to see me, hear me? Please confirm in the chat box. How are you doing? Yes. Welcome to the session, and this is a session on electrochemistry. This is Suresh, Faculty of Chemistry from Infinity Lane, is giving you the lecture Electrochemistry in one shot. How are you all doing? That's good. Very good. Nice. All the students? Good. And what are the topics that we are going to cover in electrochemistry? In that, we'll be discussing about Ahmad Sheikh, good afternoon, and galvanic cell, and electrolysis, and electrolytic conductance, and we'll be having corrosion and batteries. These are the four major topics that we can have to get a beautiful questions from this NEET examination. And Mani, good afternoon, right? And also you can see this particular electrochemistry, definitely you can expect minimum one question and at maximum two questions from this particular chapter. And without this question from this chapter, there is no NEET paper, you can assume it. So that I am going to give you a guarantee that today's class we are going to discuss everything in a one wrap. Hello, Mohammed Sheikh. हाँ, हिंदी में भी जानकारी कर सकते हैं Ahmad Sheikh, right? So in one wrap in the entire class, galvanic cell, electrolysis, electrolytic conductance, and corrosion and batteries. And you just take a book and pen and you can write all the topics that I am going to discuss in this. है ना? Right. Let's talk about first topic is going to be a galvanic cell. A galvanic cell हो क्या? So a galvanic cell में oxidation and reduction spontaneously चलेगा, and because of the oxidation and the reduction, electron is driven from one cell to another cell, and this is what you call it as a galvanic cell, where chemical energy is converted into electrical energy. So the reactions that takes place in the fundamental galvanic cell, one vessel you have zinc sulfate, and another vessel you have a copper sulfate, and zinc rod is immersed in zinc sulfate and copper rod is immersed in copper sulfate, and these two are connected by a salt bridge, where you can see the zinc is going to be oxidized, and loss of electrons is what you call it as oxidation, and the gain of electrons what do you call it as a reduction, and zinc is getting oxidized and copper is getting reduced. जहाँ पर आपका ऑक्सीडेशन होगा ये एनोड होगा, एंड जहाँ पर जिस इलेक्ट्रोड में रिडक्शन होगा ये कैथोड बनेगा, है ना? या Kavian, right? So it is based on the class 12 topic beta, and we are discussing about all the reactions that takes place in the galvanic cell. बाद में electrochemical cell and electrolysis process भी देखने हैं, and Nernst equation भी देखना है. So Nernst equation में questions कैसे आना है, सभी का सभी सारा questions आपका देना चाहता हूँ. Reactions में उसमें देखो direction of the flow, you can see what are the reactions that takes place. The reactions that takes place, zinc is oxidized, zinc is a solid, and it is going to be oxidized to give zinc 2 plus, 2 electrons are lost. This is what you call it as an oxidation, and this takes place at anode. And cathode में क्या होगा? Copper 2 plus in the aqueous state takes the electron, gives rise to copper. So copper deposit होगा, यहाँ पर copper deposit होगा बेटा, and zinc is going to be dissolved from this. So as the reaction goes on, the mass of the zinc is decreased and the mass of the copper is increased. Fine, thank you Anna Mani, and Mani, come on, and two Manis are there in the class. Kavian, right, I am from Infinity Lane, Hyderabad. Okay, so when you see this overall reaction, my dear children, these two electrons are lost, that is oxidized, and these two electrons are gained, that is reduced. So ये दोनों oxidation and reduction reactions मिलके आपका आएगा zinc solid and copper 2 plus aqueous gives rise zinc 2 plus aqueous, and copper is a solid. Okay, and this is represented by this zinc sulfate, कॉपर सल्फेट एंड कॉपर, एंड दोनों का बीच में आपका ये सॉल्ट ब्रिज दिखाया जाएगा आपका दो पैरेलल लाइन का वजह से, एंड you can see this reactions and the direction of the flow of current is going to be electron इस तरफ जाना है and according to the convention current इस तरफ जाना है. So I mean to say electrons migrate from anode to cathode by external circuit. Very good. Now who? Good afternoon. पहले good afternoon बोलना है. Right. Now, and also see what is the IUPAC representation. जहां पर जो भी galvanic cell है, LHS and RHS. LHS में आपका LHS में and RHS में, LHS में आपका एनोड लिखना है and RHS में कैथोड लिखना है बेटा. This is the simplest way, and LHS and RHS are separated by two vertical lines which includes that is your salt bridge. ये salt bridge होता है क्या, इसका काम क्या है? Okay, that is represented like this. So LHS में कैथोड क्या कर रहे? Zinc is converted into zinc 2 plus and a metal electrolyte, and copper 2 plus is converted into copper, and both are separated by a salt bridge, and it is the simplest version. And where you can see what is this salt bridge. This is a salt bridge, inverted U-shaped vessel, and it is a tube where it is filled with agar jelly along with inert salts like potassium chloride, okay, and ammonium sulfate, okay, potassium sulfate, like that, inert solvent. And this salt bridge is actually connect these two vessels, and it completes the electrical circuit, and electrical circuit का काम पूरा करना है, and physically separate the electrolyte zinc sulfate and copper sulfate electrolyte. Are you getting or not? Very good. And it is going to prevent liquid junction potential and accumulation of charges यहाँ पर है, and accumulation of charges यहाँ पर है, and it is going to be maintained, the galvanic cell maintained electrical neutrality by salt bridge. These are the functions of the salt bridge. So which of the following is true related to the salt bridge? और एक बात है, and इसमें जो सॉल्ट इस्तेमाल किया, इसका आयोनिक मोबिलिटी एंड इसका आयोनिक मोबिलिटी दोनों बराबर होना जरूरी है. एंड आल्सो you can see, and also functions of salt bridge, and that are the functions of salt bridge, and what is SOP and what is SRP. And my question is, when a zinc rod is immersed in zinc sulfate, why the electron is moving from zinc and it is reaching to copper? Why it is reaching to copper? So why not in the reverse way? That is what my question. Any question you can just ask in the chat box if you have any answer for this particular question. Why the electron is going from zinc to copper? Why not from copper to zinc? Okay, anybody can give the answer. It is a live interactive session, my dear students. You can talk to me, and if you could able to answer this question or think to give the answer, and half of the electrochemistry is yours, right? In one shot we are going to discuss, right? Okay, now you can see the single SRP, standard reduction potential, and the standard oxidation potential, and this is your standard oxidation potential when a metal, this is a metal, is immersed in a metal ion and it experiences some potential. That is what you call it as standard electrode potential. Okay, and this is what you call it a standard electrode potential. Let us say an example, when zinc metal is immersed in zinc sulfate, okay, and it is going to experience some potential at a 298 Kelvin 1 atm pressure, and this is what you call it as, electrode potential. This electrode potential, this is for zinc 2 plus, and zinc it is going to be minus 0.76 volts. You please don't have to memorize these values, exam को आपको दिया जाएगा, and it is going to be minus 0.76 volts. And if it is for the electron taking process, this is one reduction process. Electron giving process, this is what you call it as reverse. It is going to be 0.76 volts. So the magnitude of this is a reduction potential. This reduction process के लिए reduction potential मान लो, and this is a standard reduction potential, and this is the standard oxidation potential. So both values are same, but the sign is going to be different. Understand? The sign is going to be different, and that's what I want to say. SRP and SOP, SRP and SOP, right? As SOP value increases, the tendency to oxidize process is going to be increased, and its reducing power increased. And also, as SRP value increases, the tendency to reduction increases and oxidation power increases. And SRP value and SOP value magnitude for a metal is going to be the same, but its sign is going to be absolutely different. Say an example for E0 for copper 2 plus 2, copper is going to be plus 0.34, and E0 for copper and copper 2 plus is going to be minus 0.34 volts. What I mean to say here, there is no rule that SOP value should be negative and SRP value should be positive. It could be negative or positive. If SRP value is a positive, in respect to SOP value is going to be negative. That's important point as far as the electrode potential values are important, and SRP and SOP values का हिसाब से ये दोनों point काफी important है, and these 2 points are going to be connected to total inorganic chemistry to talk about P block, group 13, 14, 15, 16 and 17 and their respective properties. And you can see with respect to SRP and SOP in the D block and transition elements, also SRP values are given in the tabular form. Based on that, certain important questions are being asked in previous NEET examination. So try to be focused on the concept that we discussed, okay, and the relative tendency of the reactions that can be explained on the basis of SOP and SRP. So how do these electrode potentials are being measured? That can be explained. It can be measured by using a reference electrode. What is a reference electrode? Hydrogen electrode is a reference electrode where its value is taken as 0.0 volts, and the standard hydrogen electrode is taken a platinum, and this is your platinum coated, and it is immersed in 1 molar HCl solution, and if it is with hydrogen, this is 1 molar HCl solution which gives rise H plus, and it is connected to 1 atm, 1 bar 1 atm hydrogen maintained at 25 degree centigrade. तभी ये इसका electrode potential है, that is taken as 0.00 volt, that is E0 of H plus and H2. Its value is given 0.00 volt. Are you getting or not? Clear? Now how say? Right? Anamani, Mani, here Kavian and all students kept quiet in the chat box. Come on. And by taking this hydrogen single electrode potential, this is also called as standard hydrogen potential, this is also called as normal hydrogen potential. So this is normal hydrogen electrode. ये सारे के सारा zinc, मान लो copper, nickel, whatever the metal is connected, and the difference between these two electrode potentials are measured. Absolute value of the electrode potential you cannot measure, rather the difference in the electrode potentials can be measured by taking into the reference of normal hydrogen electrode, and these values are taken in the tabular form, that is what you call it as it is in electrochemical series, that we will discuss about this. And measurement, yes, this is your single electrode potential. Abhishek, Abhishek, good afternoon, how are you? And there is a link that is given, boost your NEET score with InfinityLearn and enroll now, and in the chat box link is available. Everybody, you can click it once and you can just experience the awesome faculties and awesome programs that is offered by InfinityLearn, right, my dear students? Okay, so you came late, Abhishek, why? And every day you just join the sessions, on the live sessions and recorded sessions be available here abhi YouTube channel mein. Everybody just make use of this and we can do the best for the preparation of NEET 2025. And today we are going to discuss about the NCERT based NEET preparation, and every chapter and every topic with related to NCERT we are going to discuss. These are the samples for that. And this hydrogen electrode, the half cell is represented for the hydrogen electrode, we already written it is 0.00 PTH plus 1 molar H2 1 atm. Its voltage is going to be 0 volts. Then the potential of SHE, standard hydrogen electrode or normal hydrogen electrode, is arbitrarily taken as 0, and it is a reversible electrode with respect to H plus, and it acts as cathode or anode. If it is acting as cathode and hydrogen is taking electron, it is reduced. If it is acting as an anode, it is going to lose the electron, and both reactions are reversible in nature. The point is very important. It is a reversible electrode. Electrode में oxidation reaction process भी and reduction reaction भी process. जाइस electrodes सबको reversible electrodes मानना. And also, which of the following is true about the hydrogen electrode? It is simply said a term, a reversible electrode, and you all maintain this terminologies more precisely to talk about the physical chemistry can have theory and logic oriented questions, my dear children. And also secondary reference electron like quinhydron electrons and calomel electrodes भी है, लेकिन ये calomel electrodes का वजह से NCERT में नहीं दिया. So I just want to talk about this version of the electrodes. And also the arrangement, electrochemical series, it is the actual governor for the entire chemistry. ये reaction होगा, reaction नहीं होगा, reaction कैसे होगा, कितना तक होगा, possibility कैसे है, feasibility and spontaneity, everything can be given based on this. And this electrode potentials that is measured by using NHE or SHE is tabular formed, that is what you call it is electrochemical series. In this electrochemical series, you can identify the chemical reactivity of the metal. The metal that has a high negative value of the S or P values or readily loses electrons can be a strong reducing agents. And दूसरा बात है relative strength of oxidizing and reducing agents. जहाँ पर ज़्यादा reducing power है, and when you talk about the electrochemical series, oxidizing power नीचे से ज़्यादा होगा. Understand? And it can be vice versa, right? That version of the table you can see, and you can see this is applications of electrochemical series: lithium, potassium, calcium, sodium, magnesium, aluminum, zinc. No need to by heart. And iron, cobalt, nickel, and also you can see tin, hydrogen. So hydrogen के हिसाब से, okay, these are all negative and these are all positive, and they are the better reducing agents, they are the better oxidizing agents. As you move down, oxidizing power increases, okay, and as you go up, reducing power increases. That's the version of the writing of the electrode potentials and electrochemical series, and displacement of hydrogen from dilute acids by metal, and the metals which are above the hydrogen can react with the dilute acids and can liberate hydrogen, and which is not possible at the down. And you can also calculate electron motive force of a cell simply by using this. You can say E cell is equal to S E naught of oxidation potential plus E naught of reduction potentials. Otherwise, you use this better way, and this is said to be EMF or E cell is equal to E naught of the cathode minus E naught of the anode, and this is the simplest way. This simplest way can give you many things. And cathode किसका oxidation potential पकड़ना है और reduction potential पकड़ना. Yeah, cathode and anode both are taken in SRP value, standard reduction potentials, because IUPAC prefers this, and the CBSE NCERT textbook also prefer these standard reduction potentials. So if something tricky is asked, you can convert this into standard reduction potential by simply changing the sign. Yes, all fine, right, Abhishek? Hope you understand. Any doubt? Kavian, Mani? Right. Nahu? Next one. And as I discussed, yes, SOP value of a series of metal increased. The tendency of oxidation increases and reducing power increases, and vice versa. As SRP value increased and tendency of reduction increases and oxidation potential increases. You all maintain these. Got it? And also you are given the standard reduction potential for the following half cell reactions are given: zinc, chromium, iron and hydrogen. These values are given. ये values का हिसाब से which is the strongest oxidizing agent, ये slide का हिसाब से oxidation potential, tendency to reduce, SRP value किसका ज़्यादा है. So SRP value किसका ज़्यादा है, and that is going to be the strongest oxidizing agent. SRP value इसका ज़्यादा है, so that it is going to be strongest oxidizing agent, and it is the best example to give the various questions from this NEET examination. Are you all ready to give one more question? And the standard reduction potentials, standard electrode potentials, M plus slash M is given. What is the meaning of this M plus slash M? It is a reduction process, right? And these values are SRP values, and you just go through the order of SRP values, so that the sequence of deposition of the metals by applying potential. So when the metal solution is electrolyzed, the metal is deposited. So I just want to say it is going to be the answer C is going to be greater than B is going to be greater than D is going to be greater than A, right? So like that you have to analyze each and every value, and don't bother about these values, and by looking at these numbers, and it is going to be an awesome journey with the electrochemistry, right? And one more question we can do: which of the following has the least tendency to liberate hydrogen from the mineral acids? From the electrochemical series, we can say the copper has a minimum tendency. You can see manganese, nickel, zinc, you just treat with dilute acids, they are going to liberate hydrogen because they are above the hydrogen, but copper is below the hydrogen, they don't liberate hydrogen, okay? And also Nernst equation. Nernst equation is very important, and it gives the quantitative relationship between the electrode potential EMF with respect to different concentrations of the electrolyte. And the electrode potential and EMF values are independent on the nature of the size of the electrode or the dimension of the electrode and size of the vessel, whatever. But it depend on nature of electrode and it depend on the concentration of the electrolyte. And you can say effect of concentration and temperature on electrode potential is explained on the basis of Nernst equation. So, for the Nernst equation for a metal is given as, so Mn gives rise, takes n number of electron gives rise M. So, electrode potential is given for, this is electrode potential EMF at that concentration is equal to standard EMF minus RT upon NF ln M by M concentration, metal concentration. It is going to be 1 because it is a solid. So, it is minimized to be, then it is going to be for the same one. So, standard reduction potential, R is a gas constant, T is the temperature. We know that standard electrode potential is going to be 8.314 and T is the temperature absolutely. You have to take absolute temperature in Kelvin, and N is the number of electrons that are involved. So, a metal N place takes number of electrons gives rise M. So, that is your N value, and F is equal to charge bared by 1 mole of the electron, that is in Faraday's 96,500 coulombs, and for pure liquids and solids it is taken as 1. And when you take these values, it is coming to be, so therefore M is equal to 1 and it comes to be R is equal to 8.314, T is equal to 298, F is equal to 96,500. If you put this in the logarithm is converted into logarithm to the base 10, 2.303 RT by NF is coming, and on simplifying this is going to be a relation, it is going to be EMF is equal to standard EMF minus 0.0591 by N log 1 by M N plus. For your copper, for your zinc, you can write it in the same way. Let us apply for our galvanic cell. For our galvanic cell, zinc copper 2 plus gives rise zinc 2 plus copper. For this scenario, you are going to get EMF is equal to E naught cell minus 2.303 RT by NF log zinc 2 plus by copper 2 plus. And when you talk about at equilibrium, you can also say E naught cell is going to be 0 and it is going to be zinc 2 plus and copper 2 plus QC is equal to KC. In general I just want to say EMF, E is equal to E naught minus 0.0591 by N log QC reaction quotient, okay, log QC. Where what is the QC? Reaction quotient, and that reaction quotient can be written like this, and at equilibrium QC is equal to Kc. Everybody knows that from the this Nernst equation is connected to equilibrium concept, my dear students. So, if you take it as 0 is equal to E naught minus 2.303 RT by 2 log Kc. So, that E naught can be calculated from that, Kc also can be calculated from this Nernst equation. Are you getting or not? And also that is the way E naught is equal to 2.303 RT by 2 or N log Kc. You can use this for any galvanic cell, any electrochemical cell. So, whenever this kind of discussions are going on, you all, yes, you are from Sri Chaitanya, Lucknow, very good, congratulations. So, Sri Chaitanya students are also attend the class for the Sri Chaitanya Infinity learned by Sri Chaitanya, okay. And also at 298 Kelvin we can say E naught cell is equal to 0.0591 by 2 log Kc. So, from there equilibrium constant can be calculated. So whatever the formulas that I am giving in the class, you all write a note, take a book and a pen, and you can go for the presentations, right? I'm from Hyderabad, Infinity Learn. Okay. PS. What is your name, beta? PS. Okay. You please regularly attend. So talking about, so E naught is equal to 2.303 RT by NF log Kc. N is the number of electrons and F is the Faraday's. Faraday value is equal to 96,500, and also you can say E naught cell is equal to 0.529 N log Kc, and also log Kc can be is equal to N E naught cell by 0.529. You can take the Kc from the anti-log, so you can also calculate Kc values, so you need not have to go. So I want to attend, but I am inorganic chemistry, chemical bonding, I have a mock test on Sunday. Tomorrow I think Monday will be having a chemical bonding, dear. Monday will be having a chemical bonding live. Okay, let's go ahead with this. So maximum reversible work done by the galvanic cell. सारे के सारा टॉपिक्स आज हमारा क्लास में एक बार रिवाइज करते जाएंगे. And the previous classes also we had a discussion about the electrochemistry, right? Now if you want to join these sessions, join. God is speaking, sir, I have a doubt. You please talk to me. What's your name? You present on Monday, okay? Fine. What is our doubt? You please continue. And delta G is equal to minus NF E naught cell. Delta G naught is equal to minus NF E naught cell, or delta G is equal to minus NE cell. So what I mean to say, when electrode potential values, hi Pratik, okay Pratik, and electrode values are not additive, but delta G values are additive. Electrode E values you cannot add, whereas Gibbs free energy you can add. So for a reaction is going to be spontaneous, this delta G value is supposed to be negative. If delta G is going to be negative, the cell reaction is spontaneous, or the reaction is spontaneous. The cell reaction is spontaneous. If delta G is positive, the cell reaction is non-spontaneous. Pratik, you tell me, अगर डेल्टा G 0 होगा तो क्या होगा? Thank you for your greetings. Pratik, you tell me, if delta G is equal to 0, what is the situation? What is the situation? If delta G is equal to 0, it is going to be the reaction is at equilibrium. The reaction is at equilibrium. Okay. Now I want to say, let us consider the silver electrode dip. It is all about the electrode potential and the solubility. Okay. So silver AgI is taken, into that silver electrode is dipped. So there is an equilibrium between AgI and Ag plus and I minus, and this equilibrium is witnessed by the silver. And you can also study from in this platform. We are going to cover 11th standard and 12th standard syllabus. जब आपका 11th standard का syllabus चल रहा है ना, ये notification में आपको दिखाई जाएगा, आप attend कर सकते हैं. And आप भी 12th standard का syllabus भी 11th standard का connected है, ये भी आप attend कर सकते हैं. So yes, there is no net change in the forward and the backward direction, my dear. So that is said to be the state of equilibrium, right? Who is that? I just Pratik is saying, and above that Pratik, I just want to know your name. Okay. Now I want to say, so the corresponding electrode is going to be I minus and Ag, I and A, and there is an oxidation and reduction process in between these two. I minus is reduced to loss of electron, oxidized to iodine, okay, and the silver plus is reduced to silver, right? And also this is a metal insoluble, salt soluble anion electrode, and based on that you can have a question from the NEET and further competitive examinations, and you can apply Nernst equation. Based on that, electrode potential of Ag plus and Ag gives rise E naught of Ag plus and Ag minus 0.0591 by 1. Why? Because silver is going to take formulas are directly useful for your NEET examination. Okay, so is my video is available and you can see my live streaming. My voice is audible, my video is visible. Okay. So for the class timing on the Monday, 1:30 p.m. 1:30 p.m. I will be waiting for you, Pratik. Okay, class timing on Monday is 1:30 p.m. And also we can go for the reaction. Ag plus takes an electron, gives rise Ag, and for the reverse is going to be, and it is going to be Br I minus, this is I minus, it is going to be 0.0591 by 1 log I minus concentration. Okay, waiting for Monday. Okay, Uday, you are the regular students previously, nowadays you are not coming, am I right? I remember you. Okay, let's go ahead with this electrode potential and solubility product. In this electrode potential, Ag plus and Ag electrode potential minus 0.0591 log 1 by Ag plus, and it is going to be electrode potential I minus Ag I and Ag minus 0.0591 log I minus, and also the overall thing is going to be electrode potential for I minus of Ag I and Ag electrode is going to be E naught Ag plus and Ag plus 0.0591 log Ag plus and I minus. Thank you very much, Uday, thank you. So you can also revert the same, and that is going to be in Ag plus and Ag, and this is going to be solubility product. And what is the solubility product? Agi and gives rise Ag plus and I minus, and the product of the solubilities of Ag plus and I minus is said to be Ksp. You put this Ksp value यही expression में Ksp value का expression आप निकाल सकते हैं. So ionic equilibrium is connected to electrochemistry. Can you believe it? Yeah. Uday, tell me what is your doubt? If the cell E naught for a given reaction is a negative value, what could happen? The cell is going to be spontaneous. है ना? In order to a reaction to be spontaneous, K equilibrium is going to be greater than 1 and delta G should be less than 1. So in order to be a reaction to be spontaneous, E naught cell is going to be positive and it is going to be spontaneous, and if the E naught cell is negative, the cell is going to be non-spontaneous. It is going to be non-spontaneous. What is the doubt, Uday, you tell me? What is the doubt? Fine. And that is your answer, delta G for spontaneous. For non-spontaneous, these are the values. Okay. Now, for the same electrodes, the concentration cells are given. Okay. Sir, if the EMF is equal to anode, and that is going to be the other side cathode supposed to be hydrogen electrode. Supposed to be hydrogen electrode, otherwise it can happen, right? I want to say concentration cells. concentration cells with the same electrode, and you are going to see two types of concentration cells, electrolytic concentration cell and electrode concentration cell. In the electrolytic concentration cell, concentration of electrolyte is different, and the concentrated electrode concentration, partial pressures are different. So you are going to have the same Nernst equation, same electrode, but the different concentrations or different partial pressures. That is what you call it as a concentration cells. And the thermodynamics of cell, it's very important. Delta G is equal to minus NFE, and delta S is equal to NF dE by dt, that is called temperature coefficient. These are all the formulas. That is what you call it as a temperature coefficient. And also Gibbs free energy and cell potential. Delta G is equal to minus NFE, we know that. Delta G naught is equal to minus NF E naught at the standard states. If the reaction is a spontaneous, delta G is negative and the electrode potential is going to be positive. And the reaction is not spontaneous, delta G is going to be positive and E naught is going to be negative. If the cell is at equilibrium, delta G is going to be 0 and the E naught value is going to be 0. So like that, various connection parameters are there. And talking about the electrolysis. Electrolysis is a non-spontaneous process where electrochemical cell, where the compound is electrolyte is divided into its elemental substance by the passage of electrolysis. The decomposition of a compound by the electric current is called as electrolysis. So for that you need a cathode and anode. Here also cathode and anode is there, and anode is a positive in the electrolytic cell and anode is a negative in the electrolytic cell. But cathode and anode are named according to their oxidation and reductions. Where the electrode oxidation takes place, that is called as anode. The electrode where reduction takes place, that is what you call it as a cathode. And also you can see aqueous solutions. When the electrolyte is electrolyzed by using aqueous solutions, you have to use preferential discharge theory. Electrodes are two types, basically active electrode and inert electrode. The electrode which participate in the electrochemical reactions is called as an active electrode or attacking electrode, whereas the electrode which do not participate in the reaction is called inert electrode. Whenever inert electrodes are there, we have to use the preferential discharge theory. This is your preference difference theory. In the presence of cations and anions are more than one, the electrolytic cell, then the ion with the same charge move towards the similar electrodes, but the ion has the more preference, alone gets discharged at the electrode. So this appears to be little complicated. I have a trick to you, and for the positive ions, this is the preferential discharge pattern. Copper is more likely to be discharged as compared to H plus is more likely to be discharged than Al3 plus. It goes like this. Okay. When for a negative ions, it is going to be the order I minus, Br minus, Cl minus, OH minus, NO3 minus, SO2 2 minus, like that. So if you memorize this, you can add a question, any question you can answer it. Understand? And you can have various questions talking about the Faraday's laws. Faraday's laws. The amount of the substance that is deposited during the electrolysis is directly proportional to the amount, the quantity of the charge passed through the electrolyte. That is what you call it as a Faraday's first law, and it is quantitatively described as mass of the substance is directly proportional to the quantity of the charge. Are you getting or not, Uday? Okay, any doubt? And it is going to be Q is equal to directly proportional to M, M is equal to EQ, and Q is equal to quantity of the charge. Q is equal to IT or CT, C is the current and T is the time in seconds. So that we can write, so weight of the substance is equal to EIT upon 96,500. That is a very important. E stands for electrochemical equivalent. I is the current and T is the time in seconds upon 96,000. You just memorize only one or two formulas. Don't derive thousands of formulas, so that you will be going to get into the complicated. So everybody written this point? Everybody written this point? Okay. For the positive ion, my dear students, you can see, yes, this is for the positive ions, right, and negative ions. If more than one ion is present during electrolysis in the electrolyte, so this is the order you have to follow. So the copper 2 plus is more likely get discharged, okay, then Hu plus, then Al3 plus, Mg2 plus, Na plus. Let us talk about sodium chloride in the aqueous is electrolyzed. You can see sodium chloride aqueous. So what happens? Sodium plus and Cl minus and OH minus 4 ions are there. So for the cathode, what happened? There are two ions, sodium plus and H plus, both are competing. But when it comes to the sodium plus and H plus, who is more likely to discharge? This is going to more likely to discharge. Uday, fine? And it is going to be discharged, but not sodium plus. So H plus is going to be discharged, so that you are going to get hydrogen gas. Clear? And also at anode, what are the ions? Cl minus and OH minus. Cl minus and OH minus is there. So Cl minus is more likely to be discharged. So that you can't say Cl minus is discharged, this is not. So that Cl minus is discharged to gives rise chlorine. You understand how to solve this question? Uday? Fine, beta? Fine. Hope you understood this. Clear? A thumbs up and fire emoji in the chat box. A thumbs up and fire emoji in the chat box. Thank you very much. Thank you. So get ready for every day. We are going to discuss this kind of things, talking about Faraday's first law. And for the Faraday's first law, this is the absolute formula that I want to give you. W is equal to E IT by 96,000. What is E? E is called electrochemical equivalent. Okay. Or number of moles can also be calculated based on that is equal to IT upon N into 96,500. What is N? Number of electrons involved in that redox change. Okay. You are from Andhra Pradesh, Vizag. I think Uday, I think you attended so many classes before this, right? Yes, you attended so many classes with me on YouTube platform. Am I right? Okay. Thank you very much for your attendance. Okay. So be regular, right? Talking about now second law. What is second law? You just see the picture here. You take dilute H2SO4, dilute copper sulfate, dilute silver nitrate. When equal quantity of electricity is passed through the series of electrodes, and you are going to get the hydrogen is going to be deposited here, and copper is deposited here, and silver is going to be deposited here. Okay, the amount of hydrogen deposited, the amount of copper deposited, the amount of silver deposited in these electrodes are in the ratio of their equivalent weight. That is what is said to be second law of electrolysis of the Faraday. That is what you call it as WA, WB, WC. So the weight of hydrogen that is deposited are in the ratio of weight of copper deposited and weight of silver deposited here is equal to ratio of hydrogen equivalent weight and silver equivalent weight, copper equivalent weight, and silver equivalent weight. So this is the order of equivalent weights. Yeah. So let us talk in this session English and Hindi or English. No other languages are entertained. Please try to cooperate with that. Okay. So based on that you can have so many questions. And Faraday is defined as, what is the Faraday is defined as the quantity of electricity required to deposit or dissolve 1 gram equivalent weight of a substance. So from this electrochemical equivalent weight is defined. Okay. Yeah, sorry, no problem. Uday, you can ask any kind of academic doubts. It is a live interactive session. You can have unlimited number of doubts. You can have unlimited number of questions. Right. Now, it is going to be 1 Faraday is equal to charge on 1 mole of electron and also charge on 1 Avogadro number of electrons. So, that is 6.022 into 10 power 23 into 1.602 into 10 power minus 19 coulombs. That is the charge on 1 electron. And it has come to be nearly, that is 96,500 coulombs. And it is 1 Faraday is equal to 96,500 coulombs. Okay? And equivalent weight can also be defined in the equivalent weight, E value atomic weight by N into 96,500, that is electrochemical equivalent. You can also say it is a Z. Okay? So, yeah, what I mean to say, when 1 coulomb is passed through 1 second, 1 ampere is passed through 1 second, is called as a electrochemical equivalent. Yes, fine, nice. And conductance, and this conductance, conductor, a substance which allows the passage of electricity through it. You have a metallic conductor and you have electrolytic conductor. And talking about electrolytic conductor, resistance is equal to rho L by A. This rho is called specific resistivity and L is the length, A is the area. So specific resistivity is equal to RA by L, and conductance is the inverse of the resistance. It is expressed in Siemens, and specific conductivity is 1 by rho, that is L by A into 1 by R. L by A is called as cell constant, and the specific conductivity is said to be G in G star. G star is nothing but specific, the cell conductivity. Okay, and we can have the discussion based on that. So, molar conductance, the conductivity offered by 1 centimeter cube of electrolyte is called as a specific conductance, and its unit is Siemens centimeter inverse. And also molar conductance, the conductance offered by 1 mole of the electrolyte is called as a molar conductance, and it is going to be K by 1000 by molarity, and its unit is Siemens centimeter square. Mole inverse is the unit. Every point we are covering from the NCERT textbook in this session. Everybody take a note and notepad and a pen, and you can write all these formulas. Are you right? Okay. And also equivalent conductivity, it is the conductivity offered by the all ions present in 1 gram equivalent of the electrolyte in a liter is called as equivalent conductivity. That is going to be K into 1000 by normality. And effect of dilution, as dilution increases, molar conductivity increases and specific conductivity decreases. This is a very, very important point. And also Kohlrausch law, and also you can say effect of dilution. If you talk about the molar conductivity and root concentration, you are going to get 2 types of conductivities. Strong electrolyte, if you talk about the strong electrolyte as conductivity regularly, can you all able to see my live streaming? Please confirm, can you all able to see my live streaming? Right. So if it is for CH3 COOH, it is going to be lower than, this is a strong electrolyte and this is a weak electrolyte. Of course weak, इसका कंडक्टिविटी इससे कम होगा, लेकिन इसका डाइल्यूशन के हिसाब से there is a sudden increase in the conductivity, whereas for a strong electrolyte there is a steady increase in the conductivity. Fine, that is the observation, very very important. And when you talk about this theory oriented questions from the NEET examinations, in physical chemistry also you can expect theory oriented questions, where I just want to say there is a steady increase and there is a sudden increase, right? That's good. That terminology is also very important. And also Kohlrausch law, it says that when complete ionization takes place in electrolyte at infinite dilution, each ion try to migrate independently and contributes to the total molar conductivity. So मान लो एक electrolyte है, AB gives rise A plus and B minus, and the total molar conductivity of AB is equal to sum of ionic mobilities of A plus and B minus, है ना? So I just want to say CH3 COOH, and it is going to give you CH3 COO minus and H plus. I want to say molar conductivity, infinite dilution, it is going to be CH3 COOH का sum of CH3 COO minus का, okay, minus plus H plus का. Understand? This is what, Louis? Thank you very much, Louis Naik. Very good. I like you, Betam. Try to understand the concepts and be present in everyday's class. है ना? कर सकते? Louis Naik, thank you very much for your display. And degree of ionization can be calculated based on molar conductance at a given concentration upon molar conductance at zero concentration, or also you can say it is a limiting molar conductivity. Okay. And batteries, talking about the batteries, battery is an example of electrochemical series. It's a compact electrochemical series where chemical energy is converted into electrical energy. There are two types of batteries, primary batteries and secondary batteries. Primary batteries is the one where you can use the battery and you can throw it once it is done, just like a battery used in the wall clock and the remote controls. Because उसमें electrolytes जो electrochemicals reactions reversible नहीं होता है, that is called primary cells. And you commonly use Leclanche cell and dry cell. And primary cells में first you dry cell consists of zinc, and this is your dry cell, right? And in this dry cell, what are the reactions takes place? Zinc and ammonium chloride and manganese oxide and carbon black is taken, and the reactions that takes place here, and carbon plus MnO2 and ammonium chloride plus zinc chloride separated by porous sheet, and ammonia produced in this reaction forms a complex. So the potential of this is nearly equal to 1.5. So what is the question, Uday, you tell me? Then the cell conductance, which 1 mole of conductance, sir? Cell conductance with 1 mole of the electrolyte is called as molar conductance. Fine? Any doubt? Okay. So the reactions that are taking place for the battery, Novino and everyday and Nippo, zinc gives rise 2 electrons, gives zinc 2 plus, and also ammonium plus an MnO2 gives rise Mn2O3 and ammonia, and this is your overall reaction. That is what you call it as Leclanche cell or a dry cell. Fine. And also you can say mercury cell. You all use mercury cell in the wrist batteries, and you can also use these things in the remote control sometimes. Okay. And car remote control, you have a mercury cell. Mercury cell is another cell suitable for low current devices, and it gives you a constant voltage. That is the speciality of this primary cell, and it is also called as a button cell. I just want to show you, this is your mercury cell. In this mercury cell you are going to have zinc and mercuric oxide. Zinc is going to oxidize to zinc oxide, and mercuric oxide is reduced to mercury. In the overall reaction there is no aqueous solutions, therefore this conductivity do not change with the concentration, therefore it gives the constant voltage. It's very important. And also secondary cells, that secondary cells, the battery once it is used you can recharge it, है ना. So the cell reactions are going to be reversible. So this is a lead accumulator or lead storage battery. This is the battery we use in the car, in the inverter, in the scooter, okay, in the motorbike. Can we write the primary cells in the important for NEET? Yes, of course. Yes, it is, Uday. And what are the reactions that are taking place in this reaction? So 38% H2SO4 is taken as electrolyte. Mind it, 38%. Okay. And lead plate and packed with lead oxide, black Pb plate packed with PbO2 act as an anode, and positive plates and negative plates. When this is connected, when the reaction is in use and the reaction is in recharged, the same reactions but reversed. A cathode become anode, anode become cathode. You can see the reactions that are taking place. When the battery is in use during discharge, so what happened? Pb plus PbO2 plus H2SO4 discharge, PbSO4 in H2O milega. Yes, Amaron battery. Okay, and during charging the same reaction you can see ulta करके लिखना, ठीक है. And anode cathode बनेगा, cathode anode बनेगा, and it is going to be so potential batteries, and we use many things. And also you can see nickel cadmium battery, पुराना का मोबाइल बैटरीज में यही इस्तेमाल करने वाले हैं. And also toys also we can have this kind of nickel cadmium batteries, right beta? Loveline Nayak, Odai Gaming, any doubts? Any doubt? Okay. And talking about fuel cell, very important thing, fuel cell. In this fuel cell, a galvanic cell directly converts chemical energy, combustion energy into electrical energy, is called as fuel cell. Yeah, you can see the video fully. Thank you very much. And और एक 5 minute रुकना, you please stay back for the 5 minutes. I am going to close the session. Okay, Lovely Nayak, Uday, you stay back. And also the fuel cell, I can just show you the picture about the fuel cell. The hydrogen and oxygen are connected here, and they are subjected for the reaction. At anode, hydrogen in the alkaline medium gives rise water and electrons, and also cathode, oxygen, water gives rise OH, and the overall reaction is going to be combustion reaction, and it is going to be a electron motive force, and it is highly important. And this image can show you the old fuel cell that has been used. Apollo space program, Neil Armstrong used this battery when the moon, the rocket launched from the earth to moon. This is the image as I just want to show you at the end of the show, right? And also various questions are ready. Yes. Corrosion. Corrosion is spontaneous oxidation of a metal when it is exposed to environment. It is a natural wearing of the metal. So mechanism of the corrosion, it is an electrochemical reaction. In this electrochemical reaction, you can see in the corrosion, iron oxidizes to give rise iron 2 plus, okay, and iron 2 plus that is going to react with oxygen to give rise Fe2O3 is the rust. For that, acidic media is going to be supported, mind it, acidic media is going to be supported to give rise these conditions, and the overall reactions, that is a cascade reaction, and the reactions are going to be spontaneous, and it is going to be anode, and it is going to be a cathodic reactions. So these reactions are given like this, and in the NEET examination, Ajay, how are you? Right. So in the NEET examination, which of the following is a cathodic reaction during corrosion? Which of the following is an anodic reaction for the corrosion? And the preventive methods, you all know, painting, galvanization, alloying, everything we studied in the schools. So in today's session, my dear students, we had a great discussion about the total Sara Sara, the composition of the rest, Fe2O3.XH2, right? Sara Sara topics we discussed, okay? And right from galvanic cell, Nernst equation, we started electrolysis and Faraday's first law, Faraday's second law, and conductance, specific conductance, molar conductance, equivalent conductance, and Kohlrausch law. Then we started with batteries, primary cells and secondary cells, and corrosion, everything. And hope you enjoyed today's session, right? Hope you understood. Ajay, Uday, Lovely Nayak, fine. And tomorrow we are going to get one more session based on hyperconjugation. Get stay tuned. And Monday we are going to get a live on chemical bonding. So what let everybody get, please like and share and subscribe NEET NCERT. Thank you very much. Thank you very much. God bless you all. Signing off, Suresh from Infinity.